Okay, everybody, welcome to COVID Calculus number 8. So in this case, we have a little funnel that's dripping a whole bunch of salt down into a conical pile. So here's our salt, right? And it's dripping down drop by drop or grain by grain into this lovely conical shape here. The cone itself has a height and it has a radius. And it's given to us in the problem that the height and radius at any given point are identical. So it's basically growing in height just as the same as growing in width, just due to gravity. All right, so we're also given that the speed at which this volume is changing, again, the change in volume, is equal to 200 feet cubed per minute. And if it's per minute, we need per unit time. Okay, so per change in unit time, it's changing this many feet cubed. It is asking a question at whenever the height is equal to 18 feet, what is the change in height? Okay, that's the question we're trying to solve. Well, we know that height is the same as radius in this case, so we can say when the radius equals 18, what is the change in the radius with respect to time? So this is the question we're asking. We're going to simplify it to radius because we happen to have radius here, and it's just easier to use a single variable, and we have that option here. So to start, we need to figure out what is the volume formula for a cone, right? We have the change in this, but we don't know what the formula itself is. So just hop over to Google. You'll see that it is pi r squared times height over 3. Well, again, we know that height is the same as radius in this case, so we can rewrite that and say pi r squared times r radius over 3. Let's make it even simpler here. So we're going to say volume equals, I'm going to pull the 1/3 out, and I'm going to multiply r squared times r, and we get pi r cubed. Okay, so there we go. There's our formula for volume here. Now, we need to take the derivative of this because we have the derivative, but we want to find the derivative of r. So we get the derivative of v with respect to time equals 1/3 stays the same. It's a constant. The 3 drops down. The pi stays the same. And the r cubed becomes r squared. We're missing one step here because we're taking the derivative of the volume with respect to time. This becomes a chain rule. We've taken the derivative of the outside function, but we've replaced the volume piece of it with r. So now we have to take the derivative of the interior function. That derivative is the derivative of r with respect to time. So we have that sitting there, and that's what we're looking for, right? That's what we're trying to solve here. And we can simplify this now. We're getting pretty close. So the 3 and the 1/3 cancel each other out, and that becomes 1. So I get dv over dt equals pi r squared and times dr dt. Well, I also happen to know this left side here, dv dt. That was given to me at the start as 200 feet cubed per minute. So let's go ahead and write that in. We get 200 equals pi r squared dr over dt. Okay, now I'm going to move this all over to this side. We get 200 over pi r squared equals dr dt. We've now solved for dr dt, but let's figure out, we still have a variable in here, r. Well, again, this was actually given to us. The question asks for when it is equal to 18 feet, right? So we can actually plug that in now. And I've already done this math, so it's 200 over pi times 18 squared equals dr over dt. Well, 18 squared is 324. Again, I've done that already. So we have 324 pi equals dr dt. And if we want, we can actually do 324 times pi, and I got a little bit of a simple calculator here, times 3.14. We get 1017.36. So it's 200 over 1017.36 equals dr over dt. And again, we can divide 200 divided by 1017.36, and we get 0.1966. 0.19 0.19666, and that's cubic feet per minute. So at the height of 18 feet, let's go ahead and zoom out. There we go. At the height of 18 feet here, the radius and the height together are both changing at a speed of 0.1966 cubic feet per minute, given that the volume is changing at 200 feet cubed. Anyway, I hope that was helpful. And as we go through this more and more, you start finding out everything becomes triangles.